Hello guys, and this is Tony once again, and today's topic is going to be about the chain rule and how to solve with it. So we basically use the chain rule when we have basically where we need to take the derivative of the outside function, but also the derivative of the inside function. And here we go. So an example of that would be like say like cosine times like 2x. You take the derivative of cosine, which would be negative sine, and then leave the 2x alone, and then times 2. That would essentially be using the chain rule to take the derivative of cosine 2x. And we're going to apply that same subject to this equation, which is f of x is equal to the cube root of x squared minus 2x plus 8. And we're supposed to find it at the point of 2, f prime of 2. So now I'm going to erase this here. So now first step we're going to do is use the power rule to get rid of the cube root and place in the front as a coefficient. So 1 over 3 times x squared minus 2x plus 8, because we're taking the derivative of the outside. So now it's going to be 1 over 3 minus 3 over 3 is the power rule. And now we're going to multiply by the derivative of the inside, which is 2x minus 2. And now, to make it easier for ourselves, let's just plug in the f prime of 2 now, which is the derivative. So now it's going to be 1 over 3 times 4 minus 4 plus 8 raised to the negative 2/3 power times 4 minus 2, which is 2. So now it's going to be 2 over 3, because we put the 2 all the way to the front to make it easier for ourselves, times 8 raised to the negative 2/3. Get out your calculator, but the answer is supposed to be 1 over 6. And that's pretty simple, right? So here, guys, is going to be our second equation, and we're just finding the dy of dx, the derivative of sine times 2x minus pi over 3 at the value of pi. So remember the chain rule. We're going to find the derivative of the outside, so dy of dx outside times the dy, no sorry, not the dy of dx in the inside, is going to be the inside times dy dx of inside. So here, the derivative of sine is going to be cosine, parentheses 2x minus pi over 3, and now the derivative of the outside, which is just going to be 2, right? So then now, because we're solving it at a certain value, now we can just plug in the value, so it's going to be 2 pi minus pi over 3 times 2. So now, because it's 2 pi minus pi over 3, we're going to get equal denominators. So this is going to be 6 pi over 3 minus pi over 3 times 2. So then now this is going to be cosine of 5 pi over 3 times 2. And if you guys recall, the cosine of 5 pi over 3, it's going to be equal to 1/2, right? Because of the unit circle and all that other stuff. So then now this is going to be 1 over 2 times 2, which is equal to 1. That's our answer. So then now this is our third equation. So this one's actually relatively simpler than the second one, because we're not plugging in and using our unit circle to solve the equation. So this one here, we're going to get the derivative of the outside, and the derivative of the outside is going to be 1 over ln to x, but our x is this inside function here. So this is going to be also times 2x squared minus 7x plus 1. So yeah. And then now we're going to get the derivative of the inside function, which is going to be 4x minus 7. right? So now simplifying this is simple. 4x minus 7 over ln times 2 times 2x squared minus 7x plus 1 as our answer. There you go. So this is going to be our fourth and final equation, and as always, I'm going to let you guys do this by yourselves and pause the video and see if you got the correct answer. Well, what you get? Well, this one was actually relatively simple if you knew your rules. So I'm going to explain it for those who didn't understand it. So basically, this right here is basically a to the x, and when we have an a to the x, we're going to multiply by ln of a, which you can see our a here is 2, and our a here is 2, right? Which is the reason why I got ln of 2 up here. And then, because it's chain rule, we're also going to get the derivative of the inside function, so it's going to be that. Well, the inside function. So yeah, it was relatively simple if you know your rules. Well, I'm glad to help you guys with this chain rule, and hopefully you guys have a great day, and take care.